I was helping people in SRT and a few people struggling on 7 and 8 on the code search. So I just wanted to go through a couple things. I think the problem here is that some of you apply different properties. When there's a negative, you decide to freak out and change all your rules. But multiplying by the conjugate is multiplying by the conjugate, whether there's a negative or positive there, doesn't matter. The conjugate is what matters. So hopefully this comes into focus. There we go. All right. So I look at this. I know that there's a binomial in the denominator, and so I have 4 minus radical 2 in the numerator. That doesn't matter. What matters is what I have in the denominator. I'm going to put parentheses around this because I'm multiplying. I'm multiplying by 1, special kind of 1. Negative 3 minus radical 2 over negative 3 minus radical 2. You don't need to change both signs. If this would have been 2 plus radical 2, you would just put 2 minus radical 2. Don't change the second. Just change the middle. Okay, so when I multiply that out, I distribute here. Well, I use FOIL. You guys distribute. Negative 12 minus 4 radical 2. And then I have plus, this is negative 3 times negative 1 radical 2, which would be positive 3 radical 2. Then I have negative radical 2 times negative radical 2 is 2. Down here, I picked this because I know the middle term is going to go away. So all I got to do is multiply the first number and the last number. Combine like terms. Negative 12 plus 2 is negative 10. Negative 4 plus 3 is negative 1. Then I just hope it's on the page somewhere. So I flip it over. Negative 10 minus radical 2 over 7. Boom. There you go. Okay, I'm going to do number 8 as well. Because if you get stuck on one of these, you can't get out of your little loop here. So I'm going to go ahead and work on number 8. Same kind of question. 2 minus 4 radical 2 over negative 3 minus 4 radical 2. Multiply by 1, which would be negative 3 plus 4 radical 2. Don't worry about the negative. So I multiply the denominator first. I get 9 minus 16 times 2. So it's 9 minus 32, which is negative 23. And then the numerator, I have negative 6 plus 8 radical 2 plus 12 radical 2 minus 16 times 2, so minus 32. And don't be tempted to go canceling stuff out unless you can later on. You combine your like terms first. That's 20, so I have negative 38 plus 20 radical 2 all over negative 23. And then I go to this problem and I go, oh no, I have negative 38 plus 20 radical 2 all over negative 23. What did I do? It must be mistaken. Well, all you do is have every sign flipped. So if you factor out a negative 1 here, you get 38 minus 20 radical 2. Factor out a negative 1 here, and you get 23. The negative ones cancel out. You have the same answer. If you can change all the signs, it's the same answer. Stop freaking out. Okay, one other little explanation that I did just to help you think about you all have radicals down really well. You don't always have the other roots. You have the square roots, but not all the other roots. So something to think about. So we know that radical 2 times radical 2 is 2. It's radical 4, but it's 2. And we know that that's the easy one. That's why we can take a radical 2 times radical 2 and get 2, because it's a square root. If I have a cubed root, then my number changes to 8, because I need 3 of them to be a perfect cube. If we're talking about the 4th root, then I need 16, because I need 4 of them to make a perfect root. So the thing you have to remember is this is a different ways to write 2. If I had the 7th root, I would need 7 2's. So I'd have 8 times 8, 64, 128. So if you have your table or not, what you have to understand is these are the roots. These are the perfect roots. Okay? When I'm doing a cubed root of 8, I know 4 goes in there. I could do this. I could go cubed root of 4 times cubed root of 2. But that is not a perfect cube. So you only want to deal with numbers that are perfect cubes when you're talking about cubed roots, perfect 4th. That's why we have the chart for you. But if you ever get stuck, break it down like it's a variable. Just get the prime factorization. So if you want to try to find the cubed root of 24, do the prime factorization if you need to. That's 6 times 4, which is 2 times 2 times 2 times 3. These 3 can come out because there's a cubed root and there are 3 of those factors, and that's left over. So apply your same rules knowing that it changes a little for each of the puzzles.